Hey everyone, it's Justin again. One of the distributive patterns we learned earlier in this unit was how to square a binomial, which resulted in a perfect square trinomial. In this video, we're going to reverse that process and learn how to factor perfect square trinomials back into a squared binomial. By the end of this lesson, you will be able to recognize and factor perfect square trinomials. To reach that goal, first we'll square a binomial and analyze the results so that we can begin recognizing perfect square trinomials. And once we know how to recognize them, we'll learn a very simple method for factoring them, which we'll practice on a few examples, including one that you'll get to try yourself. You know the drill at this point. Let's square a binomial and see why it creates a perfect square trinomial. And then we can reverse the process. Squaring is the same as multiplying something times itself, so here we need to distribute. There are two like terms, in fact they are perfectly alike, so we combine them together. And here is our perfect square trinomial, x squared plus 6x plus 9. Where the first and last terms came from is pretty obvious. They're the squares of the terms in the binomial. Look where the middle term came from, combining two copies of the same term, because we multiplied x and 3 together twice. In other words, that's twice the product of the two terms. To generalize this result, we can use a and b for the two terms in our binomial. When we square a binomial, a and b both get squared, and then a times b is also added in twice. But how do we reverse it and factor a perfect square trinomial? First, we have to be able to identify a perfect square trinomial. Which of these three is a perfect square trinomial? Well, they all have the same first and last terms, which are the square of x and the square of 5. So the question is, which of the middle terms makes it a perfect square trinomial? Think about what we uncovered a moment ago. In a perfect square trinomial, the middle term is twice the product of the terms being squared. 2 times x times 5 would be 10x. So the perfect square trinomial is this one here. And it's the square of these two pieces together, x plus 5 squared. These two binomials are almost identical, so if we square them, will their perfect square trinomials be different? Well, let's see. Same first term, same middle term, same last term. This sign is different. When the binomial had addition, it resulted in a positive middle term. But when the binomial had subtraction, the trinomial had a negative middle term. Notice how the first and last terms were positive in both of these, because squared numbers can only be positive. The only sign that can change is the sign of the middle term, depending on the sign from the binomial being squared. Let's try putting all this information together. First, pause the video for a second and try to identify which of these is a perfect square trinomial. Do you think you know which one it is? This one is definitely not a perfect square trinomial. Why is that? It's because in a perfect square trinomial, the first and last terms have to be positive. So only 2 remain. Is this the perfect square trinomial? Well, it couldn't be, because the two terms would have to be 2x and 3, but twice their product would be 12x, not 18x. So that leaves this one as our perfect square trinomial. The first and last terms are both positive. They're the squares of 2x and 7, and twice that product would be 28x. So this middle term is right. That looks like a perfect square trinomial to me. So then it would factor into 2x plus 7 squared, right? Not quite. Remember what we said about the sign of the middle term? It always matches the binomial. And since the trinomial had a negative middle term, the squared binomial has to have subtraction, not addition. This doesn't seem like a perfect square trinomial because neither 75x cubed nor 3x are perfect squares. But every term in this trinomial is divisible by 3 and has an x. So we could pull out a GCF of 3x. This leaves us with a perfect square trinomial that factors into the terms 5x and 1, and a middle term that is 2 times 5x times 1, making the final factored form 3x times 5x plus 1 squared. Pause the video and try this one for yourself. First, make sure it is a perfect square trinomial, and then factor it. Since all the terms are even, we can pull out a GCF of 2. Now it's definitely a perfect square trinomial. The first and last terms are both positive. They're the squares of 3x and 4. And twice their product would make the middle term 24x. So this is a perfect square trinomial created by squaring the binomial, 3x minus 4. Minus because the middle term is negative. The final factored form for this trinomial is 2 times 3x minus 4 squared. Factoring perfect square trinomials is pretty simple. The hard part is recognizing them in the first place. Use the practice questions on our website until you feel comfortable knowing when and how to factor a perfect square trinomial. When you're ready, move on to our next video where you will learn our final factoring method. See you then.